Are you ready to go man versus robot? Because you're about to on the People of Manufacturing. Let's go.
I love walking through any shop in America. It's got the smell of coolant, you smell the safety, got my glasses on, it's like default, you know, and I know when I'm walking into a plant, I just need to throw these things on.
What's up, Uncle Gordy? I'm glad I get to have this conversation with you. Our goal is to share the difference between manual machining and what it means to be a tradesman versus a CNC machine and what the tradesman of the future looks like. And the value of your experience, because just going through that project with you and giving you the creative freedom on a lot of different aspects to where you can change things and all the engineering aspect of it, you know more about how to make things than just about every engineer I have met.
Right, hands-on experience.
And
That's it.
So can you explain a little bit on how this, I know this is a knee mill, this is a manual mill, but can you explain a little bit on how this works?
Basically, you have three axes. You have X, which will move the machine this way. Y moves the table in and out. And your Z-axis is your quill. So basically on a mill like this you have three axes. And you make them work together to create the part. Most of the time you put the part you're working on, you can either hold it in a vise, bolt it to the table, or come up with a creative way to hang on to the part to use the machine to make it do what you want it to do.
So whenever we're working with a student, a high school student, or whenever we do outreach with people and we're telling them the industry, we explain that this is where they should start. Because understanding this and where the industry came from, it makes it so much easier for them to learn a computerized machine.
Right. And with a manual machine, it teaches you how to think and how to plan ahead. You have to know, you have to think, okay, I have to start with this block of metal. So then you have to, in your head, you got to figure out all the steps that you have to go through to come up with a finished product. You have to know if you have to mill it first or drill holes first. And like I said, it teaches you to think. And like I said, plan out how you're going to do the whole job before you even touch the material.
How many years have you been doing this?
45 years.
45 years. So,
and I still learn something new every day. Every day I'll come up with another trick or something I haven't thought about. Doing a different way to do something that in 45 years it didn't dawn on me.
Yeah.
And then all of a sudden, boom.
Well, and that's the value of why we want to do this, is because that's 45 years of hard-earned knowledge that you're not going to learn anywhere else. So the biggest thing that I want to ask you is, early on, did you have a mentor? Or can you remember that key person?
Yeah, I had a lot of older people that I worked with that were always willing to teach and show me this trick or that trick or how they did it. And that's how I learned.
And that the value that comes with that is priceless. And so, and this is also a big part of what we talk about when we talk to people in the trade. If you're going to be mentored by someone that has 45 years of hard-earned knowledge, how do you determine if someone's worth teaching?
If they're attentive and they just act like they really want to learn, you can tell pretty fast. If you show somebody some stuff and they retain it and they're happy that they learned, you can tell that they're happy they learned. That's how you tell them. When I was in my 20s, I worked with a guy named Chuck Gilmore. And he was a tool maker, he was a grinder. This guy was 83 years old. And he still worked because he loved his job. He loved to make parts. Well, I said I can line this up faster and do this faster by hand than you had to programmed all this on a CNC machine, set it all up, punched all the tools off. I can do it faster over here because it's only one. It's one of.
And that's a awesome point, because like you said, this would probably take a whole shift just to set it up to even do what you're doing.
Right, and I can do the whole job in 20 minutes.
So if it's a man versus robot, the manual machine, the robot that powers it is the brain of the human. Gordy's brain knows how to make this thing work, and doing what he's doing right now is going to take at least a whole 10-hour shift to do when he could just chuck it up and do it, because he can articulate his fingers with his brain, whereas inside of the CNC machine you have to tell it where to put it. And you have to program it in a second operation, so it's not profitable or makes sense to actually do this operation inside of a CNC machine. Uncle Gordy, it's been awesome talking with you as always, man, and I'm one of your biggest fans, so...
Stop by and say hello when you get a chance.
Done.
Now that we've seen what Gordy and the manual machines can do, let's go check out what the robot can do on the CNC machines with Bo Morgan.
A big objective of ours is to show man versus robot.
Okay.
So when we hang out with Gordy and Matt back there, it's manual machining.
Yeah. Yeah. Right on. I dig it.
So in manual machining, it has its place in American manufacturing. And we're here to determine if man wins versus robot.
Okay.
So we have a robotic CNC machine, and then you're making a part, and it starts out of a chunk of round, and this looks like aluminum?
Aluminum, yep, 6061.
And so this looks like that you have a finished part.
Correct.
So can you explain a little bit on how this part was made?
Okay. A roughing tool, a finishing tool, a tree pan tool, and a groove tool. So this part was manufactured with 4 tools.
And about how long did it take to get that side done?
55 minutes per cycle.
55 minutes?
It's a mirrored image from op 1 to op 2, so it makes the setup really easy. The tools are touched off, the machine is ready to go. Concentricity is not an issue. We go from here to here, and the concentricity, the run out, is within 2,000 automatically. So man versus robot.
So, with that being said, how long do you think it would take to make this in a manual lathe?
Double the time. Double the time, no coolant. I mean, there's so many CNC features that just trump the manual.
Yeah.
The tool approach, where we're mirroring the image, we can just flip it over and run it again. They would have to set up jaws. They would have to retouch off tools. They would have to watch their tools, where we can walk away and make money.
Gotcha. That's what it's about, right?
That's what it's about.
And how many of these guys do you have to make?
On this run, we have 3 POs for 1 order each, or 1 part each, so it's a 3-run job.
So you're looking at total, you can smash these all out in half of a shift.
Oh yeah, 4 hours worth of work.
And then
where on the manuals, you're talking a day and a half work. Plus the mess.
Yeah.
Plus the safety issues of your hair getting caught in the lathe, or there's no covers, there's no coolant.
Yeah.
It trumps it. It's hands down robot. That's the rock and roll button.
Got it.
So we basically just roughed off all the metal, and we're going to do a finish off now, finish pass.
Awesome.
So the machine's ready for it.
Ready for rock and roll?
Rock and roll button. Here we go. Go to a home position. So we take 2 thousandths per on the boss, the journals, and the overall dimensions. This tool is finishing everything in one pass. The concentricity is key.
So after the first tool ripped away the first set of metal, that's your roughing operation, right?
Yep.
And then, so this one's the finishing, so this is a little bit more of a fine touch, right?
Absolutely.
So
this is where the finish takes place, and the finishing dimensions are held.
So a new metal baby is about to be born.
Gets up to 0, so that's the distance to go. So as that number gets smaller, you're going up. You're at Z.
So this shows your position within the machine, right?
Absolutely.
So like on a manual machine, the X, Z, and B.
Yep.
Those are the moving parts and the different knobs that Matt would move back there, and that Gordy would move.
1 X and 1 Z.
Got it.
Here, when he breaks this part loose, he's going to get a different reading from this part to his next part. We're going to get the same reading within 10 thousandths of an inch.
Awesome.
part's complete. That pass is complete. We're going to go to the next hop. We'll check the part.
It's a great finish.
Yeah, very nice finish, very consistent. We're shooting for 995. We're 9946. Exactly what we planned. Nailed it. Well within tolerance.
So because of the precision and the depth that they have to go, I mean 4 decimal points, you have to be perfect. So here at Electromechanical Solutions, they also have a quality assurance department that he works hand in hand with, where they have what's called a coordinate measurement machine, the CMM. That's a big part of this business, so they can actually go after this type of precision work.
Robot wins every time.
Why does robot win every time?
You want to make 1 or you want to make 100?
Valid point.
Robots are the future.